The first sunrise on a dead world. There was a moment when Earth looked calm, but nothing was alive. No sound, no movement, no witness to the light touching the surface. Just a silent planet turning beneath an unfamiliar sky. By the time the ocean stabilized, Earth had done something extraordinary. It had survived formation, collision, fire, and flood, yet remained completely lifeless. This matters because habitability does not guarantee life. Even today, scientists search the universe for worlds that look like Earth once did, wet, warm, and stable, only to find that something crucial is still missing. The gap between a planet that can support life and a planet that actually produces it may be the most important mystery in the universe. The early atmosphere was thick and hostile, filled with gases released from deep within the planet. Carbon dioxide dominated the air, along with methane, ammonia, and sulfur compounds. Oxygen, the gas that now defines life on Earth, was almost entirely absent. The sky would have appeared dim, tinted by haze, filtering sunlight into weak, unfamiliar colors. What reached the surface was not the warm, golden light we know, but a muted glow filtered through layers of gas and cloud that shifted constantly. Sunrise on this world did not bring warmth or comfort. It brought energy. Ultraviolet radiation poured through the thin atmosphere, striking oceans and land alike. There was no ozone layer to soften its impact. Every dawn delivered a new wave of chemical disruption, breaking molecules apart while also forcing them to recombine in unexpected ways. The energy was relentless, and it did not distinguish between creation and destruction. It simply drove change. At the surface, continents were still small and unstable, rising and sinking as the crust continued to shift. Volcanoes dominated the landscape, releasing heat and gases that constantly altered the atmosphere. Lightning cracked through storm-filled skies, delivering bursts of energy powerful enough to drive complex reactions. Between the electrical storms above and the volcanic heat below, the surface existed in a state of perpetual chemical agitation that never paused long enough to settle. Earth had everything it needed to destroy life before it began, but it also had everything required to experiment endlessly. And with each sunrise, the planet took another step towards something entirely new. In this hostile calm, chemistry became the main actor. With no biology to guide outcomes, reactions unfolded freely, driven by energy from the sun, heat from below, and constant electrical storms above. Simple molecules collided, broke apart, and reassembled in countless combinations, most of them meaningless, some of them briefly stable. The planet was running experiments at a scale no laboratory could ever match. The oceans played a crucial role in this process. Water absorbed radiation, moderated temperature, and provided a medium where molecules could move, meet, and interact repeatedly. Along coastlines, tidal pools formed and evaporated again and again, concentrating chemicals and forcing reactions to restart under slightly different conditions each time. Nothing intentional was happening, but nothing was wasted either. Every failed combination left behind fragments that became raw material for the next attempt. Deep beneath the surface, hydrothermal systems added another layer of complexity. Superheated water surged through cracks in the crust, carrying minerals and energy into the ocean depths. These environments created sharp chemical gradients, places where imbalance persisted long enough to drive sustained reactions. The contrast between hot and cold, acidic and alkaline, formed natural engines powered by difference itself. These were among the most chemically active places on the entire planet, and they operated continuously, independent of what happened at the surface. Above the water, the atmosphere remained volatile. Volcanic eruptions injected gases that altered climate and chemistry overnight. Impacts from space delivered new materials, some of them rich in carbon compounds formed far from Earth. Each event disrupted existing conditions, while also expanding the range of possibilities available to the planet. What emerged was not order, but opportunity. Earth had become a world where complexity could survive long enough to be tested. Most combinations failed instantly. Some lasted longer. A very small number began to repeat. And repetition, more than complexity, was a quiet signal that something important was approaching. Repetition changed the rules of the planet. When certain chemical reactions began occurring again and again, they stopped being accidents and started becoming patterns. Molecules that could survive long enough to interact repeatedly gained an advantage over those that vanished instantly. Stability, even temporary stability, became valuable in a world defined by constant disruption. Some compounds began to link together, forming chains capable of storing information about their own structure. Others created simple boundaries, trapping chemistry inside and separating it from the surrounding chaos. These were not living things, but they behaved differently from everything that had come before. They persisted. They copied aspects of themselves. They responded to their environment instead of dissolving into it. The distinction between active chemistry and passive matter was beginning to emerge, not as a sudden invention, but as a gradual sharpening of behavior that had always been possible. Energy remained abundant and unforgiving. Ultraviolet light continued to break bonds apart, while heat and pressure reshaped matter from below. But now, destruction also served creation. Broken molecules became raw material for new arrangements. Failed structures fed successful ones. The planet was not choosing outcomes, but it was filtering them. Over time, certain systems grew more efficient at maintaining themselves. They gathered resources, repaired damage, and continued functioning despite constant stress. These systems were still fragile, still temporary, but they crossed a boundary that could not be uncrossed. Earth was no longer just hosting chemistry. It was nurturing processes that behaved almost like survival. This was a long build-up before the most important transition in the planet's history. No single sunrise marked it. No explosion announced it. The change was quiet, incremental, and easy to miss. But the planet was approaching a moment when chemistry would stop imitating life and begin becoming it. The transition did not happen with certainty or speed. It unfolded across vast stretches of time, through countless failed arrangements that left no trace behind. What finally mattered was not complexity alone, but continuity. Certain systems endured long enough to influence what came next, carrying forward chemical momentum instead of starting from nothing each time. These early processes changed how the planet behaved. Matter was no longer just reacting to energy. It was organizing around it. Feedback loops emerged, where outputs became inputs, reinforcing stability instead of erasing it. Earth had crossed a subtle but irreversible line. The surface was still hostile, the atmosphere still toxic. Yet, something new was quietly resisting entropy. This was the climax, hidden in plain sight. A world once defined entirely by fire and randomness now contained pockets of persistence. The first precursors to life did not conquer their environment. They adapted to it, surviving only by fitting precisely within narrow boundaries. Too much heat destroyed them. Too little energy stalled them. Balance was everything, and the margin for error was vanishingly small. What followed would take hundreds of millions of years to unfold, but the direction was set. The planet would never return to being lifeless in the same way again. Even when extinction arrived later, it would arrive in a world already transformed by this first breakthrough. The first sunrise on a dead world did not witness life, but it illuminated the path toward it. Earth had learned how to sustain change without collapsing, how to allow complexity to build instead of resetting endlessly. That lesson would echo through every chapter that followed. Subscribe to join the journey. The